If the laws of physics are responsible for creating the universe, we have to ask where the laws of physics themselves came from. Imagine the absolute beginning. There is no physical space, no ticking clock, and no matter. There is only a raw, dimensionless network of quantum connections, a web of mathematical relationships devoid of any physical geometry. This pre-geometric network operates under a single thermodynamic command: minimize energy and relieve internal stress. In this framework, the laws of physics emerge as the software generated by a quantum network attempting to organize its own hardware. The universe began as a blind optimization algorithm, searching for a stable state in a sea of possible configurations. Initially, the universe existed as a hyper-connected knot. In this state, every node is directly attached to every other node, creating a condition of extreme internal tension. To relieve this stress, the network underwent a topological fracture, the Big Bang. As infinite connections severed, distance appeared. 2 points that once touched directly now require a multi-step path to reach each other. This shift compiled our three-dimensional geometry. Space exists as the computed output of a network reorganizing itself to avoid structural collapse. This newly compiled space is inherently unstable. Without a stabilizing mechanism, the lattice would vibrate apart under the strain of expansion. To anchor the geometry, the algorithm ties localized sections of the network into dense, stable knots. These high-density regions are what we perceive as subatomic particles. Gravity follows the same algorithmic logic. Instead of a force pulling on objects, think of it as geodesic relaxation. The network dynamically recalculates its shortest paths. These routes bend toward the massive matter knots, minimizing total tension. This is the topological Hooke's law. Gravity occurs as a localized mathematical rewiring of the spatial graph as it updates connections. Mass and gravity function as internal load balancing protocols, preventing the network from failing as it expands. Maintaining this optimized network generates a constant stream of disorder. This thermodynamic cost manifests as entropy. While passive matter is subject to this decay, biological life appears as a predictive motif, a local structure that actively shields its internal organization from the surrounding thermal noise. These motifs survive by importing order from the wider network and exporting the resulting entropy into the vacuum. By n equals 1024 in our simulations, these predictive structures develop integrated information, a state where consciousness emerges as a highly efficient method for the network to process and stabilize its own data. Every system has a capacity limit. In the spatial network, problems arise when a localized region accumulates an unmanageable amount of information and stress. A black hole represents this limit. It is a supernode, a point where the graph hits a critical density threshold that the existing geometry can no longer support. The extreme topological tension at this supernode forces the event horizon to rapidly subdivide its edges. This triggers a localized era of inflation. This subdivision births a separate pocket universe. Because every new node in this child universe originates from an edge on the parent's event horizon, its entire volume is mathematically entangled with the black hole's boundary. Black holes act as cosmic wombs, birthing new dimensions to offload network pressure that has reached a terminal state. This process enables cosmological natural selection. The Bobby universe inherits its learned weights, the fundamental constants of physics, from the parent network. These inherited rules undergo slight mutations, mirroring a federated learning update. Over countless generations, stable universes that produce black holes survive to propagate their code, while unstable versions perish. Hawking radiation serves as the backpropagation mechanism. It sends geometric instructions and error corrections back across the event horizon, stabilizing the parent universe. The universe operates as a self-optimizing engine. It evolved space for existence, matter for stability, gravity for connectivity, and consciousness to process the very code that defines its reality.